Vocabulary is important in any subject, and algebra is no exception. For that reason, in Lesson 6.4, we're going to identify critical polynomial vocabulary. Now, some of these words you've heard before and you've used them in a different context, but this time let's look at the definitions and apply them to polynomials specifically. A term is a number or a product of a number and variables raised to powers. So a term might just be a number like 5. Or it might just be a variable like x, which is representing a number that we don't know. Or it could be a product, which means multiplication. It could be a product of those two, 5 times x. We could have powers on our variables, like 5x squared, or we might even have more than one variable. Maybe we have a 5x squared y. Each of these in the list represents a term. A coefficient is a numerical factor of a term. Factor means multiply. So if you have a number multiplied by a variable, then the number part of that is a coefficient. So if I look at 5x, 5 is the coefficient. If I look at 5x squared y, those are all multiplied together, 5 is the coefficient of that term. If I have just the letter x, then it looks like there's no coefficient there, but the coefficient is understood to be 1. We have 1x, otherwise the x wouldn't be there. So the understood coefficient is 1. The number 5 doesn't have a coefficient, and that takes us to our next vocabulary word, constant. A constant is a term that's only a number. It doesn't have a variable associated with it. And finally, we have the word polynomial, which refers to a sum of terms involving variables raised to whole number exponents with no variables appearing in the denominator. Whole number exponents means no fractions, and no variables appearing in the denominator means that we don't have any negative exponents, because a negative on that exponent, as you remember from prior lessons, means that we take that base and that power and move it to the other part of the fraction, which is usually moving it to the denominator. So our variables have to be in the numerator of any fractions that appear in a polynomial. The expression that you see here is a polynomial. Remember that poly means many, so we have many terms in this polynomial. Now, it's not required that you have many terms. You could have just one term or just two, and we'll talk about that in a moment. First, let's pick out the terms in this polynomial. I'm going to circle each term. So the first term is 7x to the 5th. That's a product of a number and a variable raised to the 5th power. My second term is x squared y squared, and it's positive, so I'm going to take that plus that's in front of it with it. The next term is negative 4xy. Notice I'm taking the negative along with the product, 4 times x times y. And then our last term is that plus 10. You might notice that it's easy to recognize the terms if there's more than one because they're separated with pluses or minuses. Next, let's identify the coefficients, and I'll draw an arrow to each of the coefficients in the polynomial that we have below. So 7 is the coefficient of the first term. It's multiplied by x to the 5th. In the second term, we have variables, but there's no number in front, so that's where our understood coefficient of 1 comes into play. Then we have negative 4 as the number in front of the variables x times y, so negative 4 is our coefficient of that term. 10 is a constant, so it does not have a coefficient since there's no variable. Constant was another one of our vocabulary words, so let's go ahead and draw a rectangle around that and draw a rectangle around the constant term in our polynomial. We can classify polynomials by how many terms it has in it. Not all polynomials get classified, but if we have a polynomial with only one term, then we have a monomial because mono means one. So one term. An example of this might be just x squared, or it could be 3x squared, but there's nothing added or subtracted. That's all one term. If we have a binomial, bi means 2, so that means 2 terms. An example of a binomial might be 2x plus 3. If we have a trinomial, tri means 3, so that has 3 terms in it. An example of a trinomial might be x squared minus 5x plus 10. Polynomials that have more than 3 terms don't have a special name. Next, let's talk about the degree, which is related to exponents in a term. So to find the degree of a term, we find the sum, which means we're adding together all the exponents on the variables. So if we have exponents on the numbers, we ignore them. We're just looking at the exponents on the variables in the term. The term with the highest degree is called the leading term. And it's not always the first term in the list. The degree of the leading term is also the degree of the entire polynomial. So if we look back at our example, if we look at the first term, the exponent is 5. So the degree of the first term, I'll just list them here. The degree is going to be 5 for the first term. In the second term, x squared y squared, we want to add these exponents 2 plus 2. So the degree of that term is 4. In the next term, we have x to the first power and y to the first power, so the degree of that term is 1 plus 1, or 2. And the degree of 10, since it doesn't have any variables on it, is going to be 0. In addition to classifying polynomials by the number of terms, like monomial, binomial, and trinomial, we can classify polynomials by their degree. If we have a polynomial that's constant, then that means it's just a number. It's not changing, like 10, for example. No variables. If we have a polynomial that's linear, then we have x to the first power. Now we might have another term in there. We might have x plus 3, but that's linear. If we have a term that's quadratic, or a polynomial that's quadratic, that means that the highest power is x squared. So we could just have x squared, or we might have something added to it, but it's not going to have a power that's greater than x squared. So we might have x squared plus x. A cubic has as its leading term x to the third power. And again, it might have other terms added to it, but it will not have a power higher than the third power. So we might have x to the third power plus 2x squared plus 4. Of course, we can have higher powers than x to the third, but they don't typically have special names applied to them. So we might say under other, x to any other power besides x to the first, x squared, or x to the third as the leading term. Just doesn't have a special name. Your practice and your mastery check for 6.4 is the complete IXL Z1. You need a SMART score of 100 to get a 5, and nothing less than that will be accepted. This is going to be easy for you to get through, but if you get stuck on a question, let me know and I'll be happy to help you.